I am joined now by Joseph DeSimone, who just gave a very important talk. Tell me a little bit about what you talked about.
Well, we developed a new process for 3D printing that actually is focused on manufacturing. And we have a pretty cool new approach that's 100 times faster than traditional 3D printing and uses amazing real materials that really fulfill an important need in manufacturing so that we can make really complex things using light that you couldn't make by traditional manufacturing, and doing it everything from sneakers with Additive to medical devices.
Yeah, it's come a long way. You refer to the concept of 3D printing as a misnomer. Can you explain what you mean by that?
Most 3D printing, I think, has been developed by mechanical engineers, and it's really 2D printing over and over and over again. And with that leads to properties that are a function of the layers. And what we do is we actually grow parts using light and oxygen. And when we grow parts, we eliminate the layers. It can be much faster and can use materials that haven't been used before. And so it's a pretty big departure from how people have used 3D printing traditionally.
So is that what you mean when you say you prefer the continuous approach as opposed to the layer by layer?
That's right, that's right.
And how is that being received so far?
Well, it's been terrific. I mean, I think it's the only 3D printing technology that can actually fulfill the needs in manufacturing. So economics, real materials, great surface finish. And so when you think about hitting quality and speed leads to scale, and that's what we're certainly doing.
Talk to me a little bit about specific materials that especially lend themselves to this kind of technology that you've been describing.
Yeah, well, I'm wearing sneakers made with an elastomer, a rubbery material that has never been 3D printed before. And so having great elastomers, whether you're making sporting goods and running shoes, or gaskets and other sorts of seals and automotive and aerospace vehicles. And so elastomers is just one example of a great material that's never been 3D printable before.
Well, I would imagine that people would just go wild about something like that. What are some of the obstacles that you have to overcome to make this kind of technology more widespread?
Well, I think it's about putting together a factory, and we talk about eating our own dog food in the sense that we're building our own factory, learning where all the pitfalls are, and then tackling one hurdle after the next. But having great partners that are committed to it, having a great team, having the resources. We have the best investors in the history of Silicon Valley coming behind us that all see the potential if you can make the unmakeable, and that's what we're doing.
So looking ahead 5-10 years down the road, what types of end products might the general public see as a result of this technology you're talking about?
I think you're going to see complex things that have never been made before. Things that might be made in one part that normally was 6 or 7 parts that were assembled. Automobiles that are more fuel efficient, lighter weight. All sorts of devices for electronics and mobile devices, and let alone sporting goods. Things that you've not been able to have before that are complex, lightweight. They use a lattice. A lattice is something that mechanical engineers have been telling us a long time is really awesome for mechanical properties and lightweight, more cost effective. But you can't make a lattice. And you can make it when you're making a bridge or a building where every strut is an individual part. But to make a shoe entirely out of lattice, it's got to be one part, and that's what we do really well.
So what kind of consumers do you see in the future?
So the consumers for us, certainly sporting goods, running shoes. Adidas has got plans for making tens of millions of these, and we'll be fueling that. That's just one example.
Okay, well, we're looking forward to seeing what comes of it. Thank you so much for joining us. We
Thank you.
appreciate it. Joseph DeSimone.
Thank you.